Good morning, everybody. All right, let's bring the energy up one more notch. Good morning, everybody. I heard some Portuguese. That's actually very nice. So I want the energy levels to be at about that level throughout this talk. And one of the things I know about myself is that I speak very, very quickly. And so if I speak too fast, I want you to yell, slow down. Because I know speaking foreign languages is hard. I try a couple myself, but let's try this together. Slow down. Slow down. Perfect. All right, that will kick us off here. So the first thing I want to do here together is I want to all get in a technology time machine. And we're going to go all the way back to 2005. Is there anybody here that was not alive in 2005? Because this was actually a very important moment for technology and humans, because this was actually the moment when I first used Facebook. I was actually sitting in French class at university, and a friend showed me Facebook. And I thought, oh, that's cool, a place where you can keep up to date with people. What I didn't know at the time was how foundational this would become to the future of the way that human beings interact. Let's flash forward a little bit, all the way from 2005 to 2022. Social media dominates the way that human beings interact online. Instagram, Twitter, these have been around in our lives for a while, but this revolution and this moment of change in humanity continues. I've got the TikTok logo up there. How many fans of TikTok? One, okay? How many people here hate TikTok? There we go, okay. So, we've got TikTok on here for a reason, though. TikTok now has 1 billion 30-day active users. So, human beings, 8 billion people on the planet, and 1 billion of them use TikTok at least once a month. And it's not just that they use it. The average amount of time that people spend on TikTok per day is 95 minutes. 95 minutes of 1 billion people's time is on TikTok. We did not know in 2005, when I was sitting in French class trying to practice my conjugation, that Facebook and social media would end up revolutionizing the way that humanity interacts. And so there are these pivotal moments in our lives when technology is a fundamental change to the things that we do. And it's oftentimes software and developers that are the ones that are making this happen. Social media created a world connected by digital content, sometimes for the better, sometimes for the worse, as we saw from all of the TikTok haters in the room. But I think that there's other innovations and pivotal moments happening right now that we should all be paying attention to. And the one that I'm talking about today is blockchain. Because blockchain creates what we call a shared truth. It's a decentralized network, it's a decentralized system that lots of people contribute to, lots of people collaborate in, and that no one individual or company controls. And this is magical for software developers, and that's what we're going to be exploring today. So this is my son, Daniel. It's actually his 4th birthday today, so happy birthday, Daniel. But yeah, exactly. Thank you for keeping the energy up. But this is his skeptical face. You hear me up here saying blockchain is going to be part of the future, and you're like, wait a minute, I don't know if I believe that yet. So who can tell me what this is? Just throw out answers. This is a creature called an axolotl, manifested as a GIF, I say GIF, called an axolotl. This is actually an NFT. All right, how many NFT lovers do we have in the room? Okay, a half hand from up front. How many people hate NFTs and think, that's crazy, what are you doing? Okay, a bunch of people here. So I actually want to say that NFTs are a concept that have been around for a little bit now. They've got a lot of press, they've got a lot of attention, but I want to be a little bit reductionist. I want all of the people in the room who are developers and who think about software to not think about the NFT, the art auctions, the $1 million pieces of art, such as this little axolotl that's dancing. I want you to instead think about NFTs as programs. This is just an application that is running on the blockchain. And it's actually a relatively simple application. It is what we call a smart contract. You can think of this as like an object, if you're familiar with most programming languages. It implements and inherits from a standard. It's got a function that tells you who owns it. It's got a function to transfer that ownership. And it's got a function that returns a URI. So when you hear about all these NFTs and you hear about all the buzz around them, I want you to think that under the hood there, it's just a program. It's a program that's running decentrally so that no one can control this, no one can manipulate this on the blockchain, that then comes to represent something through this social consensus. Right? If you wanted to represent a loan as an NFT, you could. If you wanted to represent conference tickets as an NFT, you can do that, because under the hood, all this is a program that says someone owns something using the blockchain, using their cryptographic keys. Blockchain is a place where people, we all know, buy, sell, trade things, but I also want to think about it as a large shared computing environment. Right? At the fundamentals, if you look at Ethereum, if you look at all the blockchains where innovation is happening today, people are building software. People are building software for themselves, they're building software for their companies, they're building software that interacts with other software. And that's what we're talking about today. I have one more quick story here. So how many people here like McDonald's? That's gonna be a lot of people. I'm surprised anyone was brave enough to raise their hands. Even in the US, McDonald's is not looked at as a very popular thing. But one of the things that they did in the US to market McDonald's when I was growing up was they had a Monopoly game. So every time you bought a fries or a drink, it would come with a little Monopoly piece. And if you collected the right Monopoly pieces, you could win cars and houses and millions of dollars. And so I played this game a lot. I thought it was fun. I thought, oh, there's a chance of winning. I was going to shop at McDonald's anyway. Let me try it. Let's try and win. It's exciting. But that was a trust that I had in a system that actually was not well-founded. What ended up coming out was that for a long, long time, from 1989 to 2001, there were no legitimate winners. The people that were running the system were keeping all of the essential critical pieces to themselves, selling them, giving them to friends. And so for a long, long time, I had trust in a system that I shouldn't have, because there wasn't transparency, there wasn't control of what was going on. And so with blockchain, we think that we can imagine a little bit of a better universe, because the trust that we have in institutions doesn't always work out. I mean, I believe in institutions. I think they're critical to everything we do. But anytime we can apply pressure, anytime we can offer alternatives that have privacy and control and all of these things baked in, and more transparency, that is a win for humanity. There's obviously a lot of developer feelings about blockchain. Some people, for everyone, almost everyone, it's new. I was at a conference where I interviewed 20 people kind of secretly, like I had a list of 5 questions and I just talked to them about it. And none of them knew that you could actually build, or only one person knew that you could actually build software and write it to the blockchain. And so I think there's a huge amount of potential and opportunity for us to be building these sorts of systems. But I know a lot of people think this is scary. Some people have even used the term evil or scams, because there are scams that exist in blockchain. But then there's also this excitement, this new frontier, right? There were lots of scams when the internet came out. And so we're looking at how is this going to be one of those next steps in humanity. And just to really dig into this and kind of be very eyes open, one of my favorite websites is rect.news. Because what they do is they cover all of the scams, all of the hacks, all these sorts of things. And in August alone, $200 million was stolen. That is a lot. That is very scary. This is where blockchain gets a lot of its reputation. But I also want to put that in context in terms of the trade-offs that we are making as human beings and the trade-offs we're making as developers. This is a list of the disclosed, so only the disclosed, major data breaches. And so in basically a year, 300 million people had their personal address, phone number, social security numbers, etc., compromised. Right? We have trust in these systems. We rely on these systems to keep us safe. But obviously, if companies like Apple and Twitter are being compromised and releasing personal information, some of that trust might not be founded, and we should be asking for more accountability. So what can we learn? If we take on one hand, you've got crypto, where you've got this money that's being stolen, these hacks, these scams, all these sorts of things, and you've got a traditional system where it works most of the time, but some of the promises that we're expecting, some of the trust that we have isn't well-founded. It really kind of reflects on all of us that bad software is everywhere. Right? A lot of this stuff would be fixed if we spent more time focusing on making sure that we're taking care of the users around us. So I think we all need more security. And then you should also be thinking about the optimization and trade-offs. Right? One of the things you don't hear about those $200 million amount of money that was stolen or hacked is people's information being lost. Because in general, blockchain is a place where you can control everything that you do. Cryptographic truth, this idea of shared digital consensus, really creates a world where you are actually in control of everything that's going on. And transparency is unavoidable because everything has to execute in this shared computing environment, there's nothing shady that can go on, right? You can actually see all of the code that executes. It's all immutable. Someone can't just change the way that their application works without you knowing about it. So today's plans. I'm going to talk a little bit about blockchain as a development platform. Then I'm going to talk a little bit about how you can go and learn, if this is interesting to you, if this is valuable, if you want to try and take part in this kind of pivotal moment in humanity. And then I'm going to do some demo and show you what it actually feels like to be building some of these things. And one final question before I dive in. How many people here consider yourself developers or builders? Okay, most of the room. Fantastic, because we are going to be looking at code today. And then how many people are, let's just say, JavaScript? Okay, most. What about .NET? Java? Python? Okay. You guys are all getting very good at raising your hands. I don't think I'll ask you too many more times. So we're good. So let's start talking about blockchain as a development platform. So this base unit that I alluded to a little bit earlier is called a smart contract. There's lots of different names for this. If you go on different blockchains, you'll see different terms. But the general consensus is you can call these smart contracts. And in general, smart contracts are immutable. Once you deploy your code to the blockchain, it is now going to be executed by thousands and thousands of machines around the world. Everyone that's participating in that decentralized consensus is now executing your code, validating, and making sure that the result that everyone else got matches the result that they got. And one of the interesting things about developing for blockchains that you need to know is that the cost is not the same that we have in traditional development. In traditional development, you spin up your AWS server, you spin up your Google Cloud server, and you pay for everything. In blockchain, the person that modifies state pays the cost. And this has really important implications for how you think about programs and actually even the business models that you can build on blockchain. So this actually enables models that aren't otherwise possible. So we talked about all these data breaches and hacks. So if we go back to that Facebook example, what would a decentralized Facebook look like? So instead of a single company paying for millions of servers and marketing and engineers and things like that, you could actually have a model where it's decentralized, where every user owns the private keys to their data and is in control of what happens on the network through transparency through the blockchain. But the twist there, when you look at the cost, is instead of a company paying for all those servers, it's all on the blockchain. And so it's the person that posts, it's the person that comments, it's the person that uploads something. They're going to be the ones that actually bear the cost. And so if you've heard this phrase that if you're not paying for something, you're the product, which is definitely true, it's what we see in social media, that would actually turn on its head if you built a decentralized piece of social media. Another example that I really love is we actually did this project last year where we built a blockchain-based decentralized Secret Santa. Does everybody know what Secret Santa is? It's where you have a group of people and you're randomly assigned one other member of the group and you buy them a present. It's so that you don't have this, like, if you have 10 people that I have to buy 9 other people presents. And so one of the problems with that is when you have one of these large Secret Santa systems, one company actually has all of the addresses and all the personal information for everyone that participates. But again, we've seen that sometimes that trust is not warranted. There are hacks, there's data breaches, all these sorts of things. It's a target. But on blockchain, you can actually build a fully decentralized one where only the person that uploads their address and the only person that receives that person through the matching could actually see and get those private keys to that address. So you could have a truly Secret Santa where there's not some central party that you have to rely on. The other thing to really think about in terms of business models is that a lot of this is actually financially linked. So because you have to pay to engage and interact with the software, there's actually kind of money in stake. So we'll see things like decentralized finance is huge, right? People using blockchain, using these autonomous systems in order to exchange funds. And I use that term autonomous system really intentionally, where if you think about the decentralized Facebook, right now Facebook has a lot of profit incentive to keep making Facebook better and better and better. But if you had a decentralized one that was immutable, the profit incentive for that company in some ways goes away. Obviously, there's tokenomics. They can ship a token that then has some utility in the system. But in a lot of ways, that Secret Santa system, I no longer control it once I put it on the blockchain. That now just exists as a public good that anyone that wants to interact with it can. There's also this concept of immutability. Most of the blockchains that people develop for are immutable. Once you put something up, I can't change it. And so that has radical implications for how you think about your development lifecycle, your update path, all of these sorts of things. And I really think that when you do this, you can actually build something bigger than yourself. If you look at the DeFi apps out there and the decentralized exchanges and things like that, and even things like Tornado Cash, which are very, very controversial, in some ways, you're putting it out onto the blockchain, and then it lives and it can have a life bigger than even what you intended. And all of these autonomous systems come with kind of baked-in user control, right? The only thing that can interact with the blockchain is a blockchain wallet or someone representing a blockchain wallet. And so everything that you do, you're in control of, and we'll see that in a little bit. And so throughout this presentation, I'm going to give simple, imperfect answers. Obviously, there's a lot of nuance, a lot of detail. You could spend hours and hours and hours learning about blockchain, but I want to simplify things. And so what I would say is, if you are thinking about getting in this space, start with Solidity. So that means EVMs, and we'll talk about that. There's a testnet called Gurley. Use that one. There is a chain called Polygon. It's very cheap. It's a great place to get started. And then there's a development framework that's built on JavaScript and TypeScript called Hardhat, which you should take a look at. Now, I'll talk a little bit more about all of these things. But one of the problems that we have in blockchain is that because there's so much innovation, because it's so early, there's thousands of options. And so this can often be intimidating. This can be daunting to people that are looking to get started. And so what I'm trying to do here is shine a lit path that a lot of people have followed, that you won't fall off the bridge too early. All right, so let's talk about learning blockchain. So if this has been interesting, what do you actually do? So this was me in 2021 when I first started deploying blockchain. So as you can see, I was at the party, but I was still a little shaky. I was confused. I didn't know what was going on. Too many hats. But one of the ways that you can think about this is blockchain in some ways is just another backend. We're used to accessing RESTful APIs. We're used to accessing services across the web. And you can start thinking about blockchain in the same way. So you have your standard web front end that you build, and then instead of interacting with a server, you can interact directly with the blockchain. So I mentioned Solidity. This is the programming language that most smart contracts are built in today. It is object-oriented, as you can see. You've got this idea of contracts, you've got variables, you've got methods, and all of this code gets compiled and shipped to the blockchain just like you would do with a normal application, but instead of that backend being your servers, it's the entire chain being executed by thousands of computers. And so if you're looking for a journey on how do I get started, one of the first things I'd recommend is just connect to some existing data. Build a front end to some data that exists on the blockchain and see, okay, what does it feel like to query that? What does it feel like to interact with that? And then once you move into building your own dApps, your own smart contracts, you're going to get a little bit better. You're going to understand, hey, this is actually this autonomous system that I can build, and how can I make it upgradable? How can I make it future-proof? All those sorts of things. And then don't forget to productionize, right? We saw all those privacy violations in traditional development. We saw all those hacks and things like that in blockchain development. Make sure you think about productionization. There's also 3 paths that I recommend, so depending on the modality that you care about. We've got video. So one of my team members at Chainlink Labs created a fantastic 16-hour course on Free Code Camp that walks you through everything building blockchain, from like your first smart contract to like shipping DeFi applications. And then we decided, hey, let's actually go one step further and let's ship a 32-hour version built on JavaScript. So this is one of the best tutorials out there. And I'm a big fan. I've heard from lots and lots of people that this was helpful because it walks you through basically every step of the way. If you don't like watching videos and following along, then I would recommend, if you like gaming, there's, anybody heard of Flexbox Froggies? Okay, a couple of people. If you're ever trying to master CSS in Flexbox, check out Flexbox Froggies. It has you playing a game where you have to put frogs on lily pads by using the correct Flexbox specifiers in CSS. And so they have a similar thing called crypto zombies, where you can build a smart contract, you create a little zombie, and then you go from there. I don't know why the screen is going in and out, though. And if you just want to get into some code, there's a fantastic tutorial called Speedrun Ethereum, which is all about, hey, let's go build this, and here's some sample code, and then let's go build this on top of that, and here's some sample code. And really just trying to accelerate you through with code-based examples. There's also a IDE that I want everyone to give a try. So it's Remix, and I'll be demoing it here today. But remix.ethereum.org, it's a little bit like if you think of StackBlitz as for being kind of traditional Web 2, Angular, React, all those sorts of things. StackBlitz is designed for blockchain, where it's got the code highlighting for Solidity, and then it's actually got the ability to deploy to blockchains directly from Remix. And we'll be giving this a try. So if you're learning, stick with the skills and tools you know. If you're a Python developer, use the Python-based tools, right? There's great frameworks like Brownie that are built on Python. If you're JavaScript, .NET, use tools that look like the tools you're very familiar with. Experiment in Remix, and then at some point, once you feel comfortable, graduate into a more full-fledged framework. So, everybody ready for a demo? All right. So there's two demos we're going to do depending on how we do, if the internet works, all those sorts of things. And so the first one is I'm going to build the simplest smart contract I can think of, which is a counter. And then we'll go through and if we have time, we'll build a fully decentralized raffle that is like one of these autonomous systems that I was referring to that's kind of bigger than us. So here we go. So let me set the stage here. So I have a couple things up here. I've got Remix. So this is that IDE that I referred to. This is that web-based IDE that's going to allow me to write Solidity. We'll compile and deploy directly from here. And then I also have this little Angular application that I built that is I call it the operator tool. This is a way of interacting with the blockchain. So again, I talked about how you can build a new front end that exists on top of an existing backend. Because all this is public, because all this is transparent, you can build a new front end to connect to any smart contract out there. All you need is its API, or what in blockchain what we call an ABI, application binary interface. So what we're going to do is we're going to jump into Remix here, and let's build a contract. So as you can see, this is a relatively simple code example. You've got the which compiler version we want to use. We've got the object here, and I'm going to create a uint public counter. Can anyone guess what this does? We'll make a constructor, and we'll say counter equals 0, and we'll make an increment method which takes counter equals counter plus 1. All right. Is anyone confused by this code example? I hope not. It should be pretty simple. And now what I'm going to do is I'm going to go ahead and compile it. So we're going to say compile counter.sol, and then we can actually, there's two ways to play with this. I'll just do it both ways just to demonstrate. So you have to deploy that smart contract now to a blockchain. And so Remix, one of the things they have is they have a virtual machine, so you can just deploy directly in your browser. The only thing you can't do here is you can't interact with other people's smart contracts. So if we hit deploy, it'll deploy to a little fake blockchain, and we will see our contract here. We should see a counter that has 0. So you click on counter, that calls the, it checks the blockchain, your little virtual machine blockchain, for the value, and then you've got a method here. And if I click increment, it will actually go ahead and create a transaction on that blockchain that runs this method. And if we check the value of counter again, it should be 1. Success! First demo successful. That is a good start. Now, one step further you can go. So as you saw, this is how you do it in the virtual machine. But let's talk about that model of actually deploying things to a shared blockchain where you actually have to pay for things. So one of the ways that we deal with this when we're actually building software is we use what are called test nets. So these are test nets that theoretically should have no monetary value, and they should have the currency that you need to perform transactions available via faucets, right? So you just go to a faucet, you say, hey, I need some of this currency, it gets sent to you, and then you can use it to interact. So what I'm going to do is I'm going to switch over to what's called the injected provider. So this is going to use a browser extension that I've got called MetaMask. There's lots of wallets and things like that out there. I recommend MetaMask if you don't know what you're doing. Just give it a try. And you'll see I've got 216 units of imaginary currency. And what will happen is now every time I try and do something on a real blockchain, because the testnet is a real blockchain, you've got thousands of computers running that code, or hundreds of computers sometimes, and I hit deploy. When I hit deploy, to actually put my contract into the blockchain, into the state machine of thousands of computers out there, I have to pay this imaginary currency, or a real currency if you're on a real network. So 0.0003, okay, yeah, we can afford that, of the imaginary currency. And what we should see is that once that comes back here, so again, because this is a real network with thousands of machines actually executing this code, we have to wait. It's all asynchronous. I have now submitted that transaction to the blockchain. So all the machines will say, hey, do we want to include this transaction? Hopefully, yes, they decide to. Otherwise, these demos will not go well. Make sure I have internet. All right, there it is. So the network now has all agreed. We've achieved consensus. My smart contract belongs on the network because I paid for it, and now there it is. So what we can actually do is we'll go over here. We'll use my little Angular app. I'm going to copy that interface, that ABI. So it's basically just the signature of your contract, and I will go into this little tool that I created and say counter, or Porto Tech Hub counter, and I will paste this in. Paste that in. So now we see the signature that we just created. So you've got inputs, you've got a method, you've got functions that modify state, things like that, and we'll just go home here. And now what we'll do is we'll connect our front end to that smart contract. And so what I need to do is I need the address. Where was that deployed onto the blockchain so that we can find it and refer to the right thing? Because theoretically, I could deploy the same contract hundreds of times with different addresses, right? And so I actually need to know which version of that contract I've deployed. All right, when we connect here, we should see, no, that is not the right contract. Counter. All right, here we go. We should see two methods, just like we saw before. We should see a counter, and we should see an increment method. So it's back to 0 because this is a new deployment on the blockchain. And when I call increment, now in order to activate that method, in order to actually do something on the blockchain, again, that's a transaction. And so I have to submit that to the blockchain and they all have to agree on it. So in general, there's two ways to think about this. You've got methods that don't modify state, and anyone can do that for free. There's no cost, and anyone can read the state, right? All you have to do is spin up a node or access it via a node provider like Alchemy. And then there's transactions that actually modify state. And transactions that modify state, you use the currency and you pay for those. And then as soon as the network has achieved consensus, our counter should bump up to 1 here. But you can see that transaction is there. I don't know if we want to wait for this because the internet's not being super reliable right now. Yeah, see, it says the transaction is pending. And there we go. Network has achieved consensus. And so now when we query, we're going to see that our counter is 1. All right, we've successfully deployed to an actual public blockchain. So this is, again, code that is now, that little 1 exists on thousands of computers out there. And they all agree that the number is 1. All right, so let's dive into our next demo, which is going to be a little bit more complex. All right, so yeah, we created a publicly visible counter and allowed anyone to increment the counter. So right, it wasn't just me that could increment the counter. You, if you connected to that backend that I just created, you could increment that counter. All right, demo tool, demo 2. This is going to be a little bit harder. So I want to build a raffle. So a raffle, just so that we're all using the same definition, is a thing that anyone can enter. So you're going to join the raffle, and then we're going to pick a winner. So this could be money, this could be prizes, this could be cake, this could be tickets to the conference, whatever this is. And so what we'll do is we'll create a smart contract raffle, and then we'll use the ABI and then go have to interact with that raffle, and we'll try and make it truly random. Because one of these things is, how do you pick something fairly, right? If you control the system, if you control the back end, everyone has to trust you that you're not going to change the way that the winner gets picked. But in blockchain, there's actually ways to do this with trustless, so that even I, the person that created the application, cannot manipulate the results. And the way that you do this is something called verifiable random function. This is a hardcore piece of cryptography from like the 1990s. Basically, it gives a random number in a way that is verifiable by external parties. So I've got a secret algorithm for generating random numbers, but it's a secret algorithm that generates a signature that you can verify that shows that I use the same algorithm every time without me revealing that algorithm. It's a type of zero-knowledge proof. And so basically, I have a private key that allows me to create that number, and you have a public key to verify that random number. So that's what we'll be using. So the steps we're going to follow is on the blockchain, we're going to create, we're going to use just a Chainlink VRF example, and then we're going to turn that example code into a raffle. And then in the front end, we'll connect, we will enter the raffle, and we'll hopefully pick a winner here. So let's again go back to the code. So the thing I am going to start with here is called raffle sold. And so this looks like a lot of code. It's not actually that much code. This is straight out of the documentation from the Chainlink team on VRF. And so basically what you have is, if you remember, you've got that party that's going to supply us a random number that we can prove and is verifiably random. And so what we've got here is we've got the contracts for that. We've got the key, the public key that we're going to use to verify. We've got a constructor that just sets that up. And we've got this method that calls that method to request a random word. And then you've got a callback once that randomness comes back. And this is actually something interesting to think about, because one of the problems with blockchains being deterministic is that everyone knows what the methods are going to do before they execute, right? So if you naively tried to implement, like, let's just use a hashing algorithm to get a random number, I will actually know the result of the calculation before it's executed on the blockchain. And so then I can just do things to manipulate, and I can say, hey, I don't actually like the result of that raffle, let's just run it again. Let's run it at a different time. Let's do things that manipulate that random number that increase my chances of winning. Whereas if you use something like verifiable random function, I can't manipulate it, right? It is, I put a request in, and then it's like commit reveal. There's no way to get out a wrong result or to manipulate it, because it doesn't matter how long you wait, doesn't matter what you do, that number is always going to come out the same. And then you've got a modifier here that just says, only allow me, or wait, we didn't actually use this, so Actually, only the owner of the contract. So only the person that created the smart contract can call pick winner. The method we'll create in a second. So first, let's make this a raffle. So we've got some raffle vars. So we're going to need an address array of entries, and we're going to need an address of the winner. So again, an address in blockchain is just the wallet that it's an address to a wallet. So when you enter the raffle, we will save your wallet and we'll say, hey, this is entry number 0, entry number 1, entry number 2, as many entries as we get. And then once we pick the winner, we'll save that here as the winner address, and then we'll know who won based on that. And again, we don't know your identity, we don't know your name, we don't know your address. Everything is just via this public-private key wallet that you're using. All right, so first thing, or the next thing we'll do here is we're going to change request random words. We're going to call pick winner. So this is just a method that we're giving ourselves that whenever we want to pick the winner, whenever we want to end the raffle, we will call this. And then it's actually in the callback where we're going to implement our use of that. And so, actually, we need an enter method too. So let's go up here and let's say function enter. And so anyone can enter, so we're not going to make it only the owner. And what I'm going to say is entries.push, and I will add the sender of the message. Pretty straightforward. Anyone that calls the enter method gets entered into the raffle. Makes sense? So if you, on your phone, on your app, whatever device you're using, enter the raffle, which I won't be walking through here just for time, but then you would automatically be entered into the raffle. You'd be added to this array. And then in the pick winners, it's actually relatively simple as well. So we just say, hey, we've got this random number now. So let's say winner equals the entry item, which corresponds with our random number here. Where is it? Oh, no, it's sorry, down here. So we've got this random words. So we can say random words, get the 0th random number we got from there, and we'll mod it by the list of the length of the entries. All right, so I think I've done this right, but we will deploy it to a blockchain and actually see. I've got my secret steps here. Yeah, I think I did it all right. All right, so first we're going to deploy that. So it's compiling, expected semicolon. I think that was just the comment I had in there earlier. Let's see if we can recompile. Maybe this is an old error and we can just dismiss it. Let's just try and ignore it. That always works for errors. All right, so let's go ahead and deploy no compiled contracts. We might be running out of time here. Let's just try one thing. Invalid input source specified. All right, I'm going to refresh. Let's get risky. Here, let's copy and paste the code we just wrote. Tech demos are always doomed to failure, just so we're all on the same page. And the browser's not reloading. Oh, I think we might have an internet issue. What's that? I lost the Wi-Fi connection? Well, that's not going to work then. So, and this actually highlights one of the kind of inherent interesting things about blockchain is if I want to build an app that works with other people's apps on the blockchain, I need access to a testnet. And that testnet is going to be on the internet. So you can mock everything and I can build locally, and anyone really does that for real development. But at some point you should deploy to a testnet and actually interact. So if you want to see what your application looks like on OpenSea, sorry about the blinding square. That's terrible. Let's get away from there. And then we'll, okay. Everybody close your eyes. No, it's not back. All right, let's just see if we have a backup here. Do we have a backup? No, I think I deleted the backup this morning. No, all right. Because the internet is not working, I'm going to just keep moving. So I apologize. If you want to come see me later, I'd be happy to show you this demo. There's also code that's on GitHub that you can check out. But again, the principle is that we are creating a raffle. Basically, we're creating an array that it lives on publicly on the blockchain. Anyone can add themselves to that array. And then you pick a winner, and it's going to use this verifiable random function to randomly pick a winner in a way that I cannot control. And that is something you cannot do anywhere in traditional development. So that's kind of the magic moment here. Again, I apologize. I wish I had a little bit more internet. This all worked before you all got here, so maybe this is your fault. All right, and will my slides not load either? That would be fun too. Maybe we should go in airplane mode. So here's a weird question. It says down in the corner, waiting for play.google.com. Why does Google Slides use play? All right, so in summary, when you head home today, I want everyone to remember, I want everyone to forget about the traditional definition that you have in blockchain of the scams, the problems, NFTs if you want. Think about blockchain as a dev tool. This is a tool that you can use to build software that is part of this decentralized consensus, because as more and more technology goes into the blockchain, more and more of our lives are being built in these transparent, trustless systems. The sooner you can get in and try things out, the more influence you're going to have on making that a healthy, happy, successful ecosystem. I would definitely use it responsibly. Think about productionization. Think about security. And here's the repo if you wanted to give any of this code a try on your own poor Wi-Fi internet connection. So that is going to be it for me. Thank you so much for the time. And definitely come have a conversation. Come reach out to me. Send me an email. Send me a tweet. Happy to answer any questions people have. I don't know, someone else is going to come out. Anybody have like 1 or 2 questions that I can answer? I think we have a couple minutes because the internet went out. Sure.
Avalanche testnet.
So yes, why did I use the Avalanche testnet, not the Ethereum testnet? Speed. For demos, the Avalanche testnet agrees on consensus faster. The Ethereum testnet, it takes around 15 seconds to have a block, whereas the block time is shorter on Avalanche, and I don't actually care about the finality of that consensus. And actually, I recommend it to everyone else. Don't use Fuji. Use Gurley. Is what I recommended. So just for demo, just to make the demo look good when I have an internet connection. I think we have time for one more question if anybody has a question. Going once? Going twice? All right, well, thank you again. Have a fantastic conference.